This video is part of my software engineering series, 3 common problems and 3 solutions. In this part, you will see the second problem. Objects that create other objects causes coupling. And solution, solve coupling with dependency injection. In 2013, me and my team created the Windows version for Wunderlist in Berlin. At that time, Microsoft was working on a unified Windows 10 platform, but Windows 8 and Windows Phone 8 were still based on different Windows operating system versions. Although 80% of the code could be reused, there was a big chunk of code that was platform dependent. For example, loading and saving data worked differently across platforms. Although back then our code was written in C# and XAML, I will use Python to demonstrate the problem. Look at this code. The class initializer takes a platform string. The load method switches on it to load data from the appropriate platform. It then mixes this functionality with deserializing data. I add a save method. Notice that the save method serializes data and then mixes this functionality with saving on the appropriate Windows platform. I create a main script to hook everything up. An instance of data is made with string Windows 8. What happens when I execute the code? That works. The data was loaded and saved to the Windows 8 platform. Look at class data again. There is a problem with this code. It violates the single responsibility principle because it mixes loading and saving with processing data. Fixing the problem goes in 2 steps. Extract the loading and saving functionality in individual classes and methods. Abstract and decouple. I start by extracting the loading and saving functionality to new class storage. All the Windows 8 loading and saving functionality is now extracted to this class. I do the same thing for Windows Phone. This module now has a single responsibility: deal with data storage. So, what are my options how to use it? I could use the data class initializer to create the appropriate storage instance. For this, I need to import the classes. I now use the storage instance in the load method. And save method. That cleans things up. I'll test it. That still works. The system already has much improved. Each part of the code has a single responsibility. Here is the dependency diagram. It is created by following the import statements. And the diagram shows a new problem. To instantiate the storage instances, the data module is coupled to the storage module. You can see this in the code. By looking at the import statements, and the object instantiation. This code still has two major problems. The open-close principle is violated. When storage classes are added or removed, the data module must also change. The single responsibility principle is still violated since the data module is responsible for creating the proper object and then using it. I'm going to fix the problem by inserting an interface between the data and storage module. If you are watching this video, I guess that you like software engineering puzzles just like I do. But what I never got is why some books need 500 pages to explain these down-to-earth concepts. So I did something different. I created an ebook where I explain 3 common problems with solutions. And instead of having to read for 2 days, you can now read it in 5 minutes. But it gets better. You don't have to discuss with Bert anymore. You see, Bert hates patterns and principles. And instead of wasting your time convincing him, you can now just send him a copy of the ebook and proceed with more important things. A link to the ebook is in the description. Now let me add a storage interface to the system. For this, I will use a protocol class. Instead of passing a string to the class initializer in data, an instance of type storage will be passed. I store the storage instance. And replace the imports. Class data is now decoupled from the storage module. All it knows is there is a load and save method, but it has no idea where the actual data is coming from. All that needs to happen now is that main instantiates the proper storage instance and pass it when instantiating an instance of data. For this, I have to import them. Instantiate one and pass it to data. That should work. And it does. Data is now fully decoupled from storage classes. To let it work with a different storage, main can pass the appropriate storage instance here. By the way, you might ask yourself how the interface is enforced by Python. Well, you might have already guessed it is not. But by using a protocol class, the static type checker is capable of finding errors. I can easily demonstrate this by renaming the interface method names. For example, when I rename load to load2, Visual Studio lights up like a Christmas tree. When I hover over the wiggly lines, it shows me the problem. This kind of type compatibility is known as structural typing. I describe this and many more typing techniques in my course, The Python Type System. I'll put a link to the course in the description. Now that dependency injection is used to inject the proper storage instance, you can go wild with all the possibilities. For example, you can add a mock loader to the system without having to change the data class. All you need to do is instantiate the mock storage class in main and pass it when instantiating data. You now can work on the system without access to a local storage. And hard-coded data like this is also great for unit testing. But why stop here? Abstracting classes behind an interface can also be done when using external libraries. And to see how that works, click on this video. There you learn how to load Excel sheets and hide all the functionality behind an interface.